Okay, so this is our fourth equation, problem for predicting the products. Once again, what type of reaction is it? Generally, when you've got a lot of stuff and it just looks like a big busy reaction, and there's no carbon and hydrogen and oxygen, it's a double displacement. I have two ionic compounds over here on the reactant side. This is a double displacement reaction. Okay, what are my formulas for the products? Well, the way these work is we're going to take the ions, and just like in a single displacement, they're going to move around. The difference is that in a double displacement, there's a negative ion, there's an anion in both reactions, or excuse me, in both compounds, whereas in our single displacement, only one of them was a compound and the other one had to sit by itself. So these are going to be our new products. I'm going to take the silver and put it over here with the phosphorus. So I'm going to have silver phosphate. So silver, remember, is an Ag plus, and if you didn't know that, you could tell that from this compound up here. Okay, and phosphate is a PO4 3 minus, so that's going to be Ag3 PO4. And then I'm going to have potassium nitrate, so I have K plus and an NO3 minus. No extra charges, so I don't need any extra numbers. That's KNO3. So those are my two products. Phase labels for the products. Well, double displacement reactions, we can't simply tell by looking at it what it's going to be. So what we need to do is to get out the table. And look, so here's silver. My first product was silver phosphate. So here's my silver. My phosphate, again, you can't see it. See if I can get it almost in. There we go. Here's my phosphate. We look to see where they meet, and there's an I right here. I means that it's insoluble, so it is going to be a solid. And then potassium nitrate. My potassium is here, and nitrate is there. So we look where they meet, and that has an S. That stands for soluble, so it's going to be an aqueous substance. Okay, so then our balanced reaction, we have our reactants that I gave you, PO4 aqueous plus AgNO3 aqueous is going to produce, we had Ag3 PO4, which we said was going to be a solid, plus KNO3, which is aqueous. Now, I don't have a lot of room because I don't have so much room to write my symbols down here. I'm kind of going to do this in my head. I know that I have 3 potassium atoms over here and only 1 here. I'm just not going to bother writing the lists out. So I'm going to put a 3 so that I've got 3 potassium atoms. And I also know that I have 3 silver atoms and only 1 silver atom over here. So if I put a 3 here, now I've got 3 silver atoms on both sides, and you'll notice that I have 3 nitrate ions on both sides also. Okay, is the reaction spontaneous? Well, with a double displacement reaction, we're looking at the phase labels of the products. I have a solid and an aqueous. Anytime you have a solid as a product, my double displacement reaction is spontaneous. If both of these two things are aqueous, then this reaction does not occur. Okay, because aqueous solutions are clear and are going to be clear. And we've seen before, if you drip 2 clear liquids together and you get another clear liquid, clearly nothing happens. So, okay. If you're looking for problem 4, I'm not going to do it in the interest of time here. Problem 4 is a combustion reaction. The products are carbon dioxide and water. You can get it from there. Okay, best of luck.